you will need an Arduino Uno microcontroller or any other similar one, a breadboard, an HC-SR04 ultrasonic sensor to measure distances, a sensor bracket to mount on a servo, and then lastly you will need a servo which can rotate to at least 180. This here is my circuit diagram. My servo is connected to pin 11. For the ultrasonic sensor, the trigger is connected to pin 9, echo goes to pin 10. The breadboard is for the common ground and the voltage inputs. And also the servo should be mounted below the ultrasonic sensor via the bracket. So the Arduino code is very simple. Since we'll be using the servo object and the ultrasonic sensor, we just have to configure those. I start off by including my servo.h and defining a servo object here. For the ultrasonic sensor, I have a trigger pin, which is pin number 9, and the echo pin is pin 10. I also have variables here for the time duration, the distance traveled, and the servo setting, which is the servo angle. In my setup, I initialized my serial at this rate. I attached my servo to pin number 11 since that's what I'm using. And for the HC-SR04, I defined the output and the input pins respectively. Since I want the radar to start at a 0 angle, I assign an angle of 0 to the servo at the start. Inside my loop, which repeats over and over again, I have these 4 lines here. The first one is the move servo function that pretty much gets the angle from the user interface and then passes it on the servo. So it just writes it over there. The next is the get distance, which finds the distance from the ultrasonic sensor every time. You simply have to pass in a low signal, a high signal, wait 2 microseconds in between, and then wait 10 more microseconds. You just get the duration of the time and then multiply it by the speed of sound and divide by 2. This is standard code for the HC-SR04, so no matter which project you're working on, you will always have to use this exact code every time. And then lastly, I just print the distance, and this will pass it back in the UI. You see how the user interface actually reads the distance and tells you it on the screen? So you can do that by passing in serial.print. This will go in the QSerialPort and then be passed over to the UI where you will actually see the value there. Okay, let's go over the Qt code and the UI. So this here is my UI itself. I have 5 buttons on the top left which specify the angle which I want the servo to rotate to from 0 to 180. I have my angle value which will update based on what the angle is. That's my angle label. And then the range value will be passed over here. On the right, you can see the labels which I have used. And every Qt application has this. You need to use Qt Creator to create this UI here. I also have a vertical slider bar which can be dragged from any value. So it's set to 0 to 180 because that's my servo range. And then for the radar itself, I have a Q graphics view item. Now this item can be used to draw polygons and shapes. You can also fill it with an image. I'll be filling this with an image and then drawing the needle on top of it. It's called graphics view, as you can see here. Now naming this is very important because when you specify commands inside the code, you need to actually get the name of the object. So that is why I've given everything a clear name so it can be easily referred to after. So with that being said, let's move on to the rest of the code. The first thing I did was add a resource file. This is my radar image here. It is a polar plot and the resolution is 1000 by 500 pixels. Now based on your application, you can have a different size image. That is no problem. But you do need to keep in mind the resolution because in Q graphics view, the origin is at the top left usually. So the x-axis points the top left here and the y is like bottom. Now this is a problem because when we actually draw the needle on the radar, we'll be using the polar plot formulas and that assumes that the origin is here, right? Because if you look at x equals r cos theta and y equals r sine theta for a circle and a point located at some radius r from the middle, it'll assume that the middle is the center of the polar plot. So we need to actually do an axis transformation. And in this picture, you can see how I did it. I need to know where my middle is located based on the top left corner. So for my case, it is 505 pixels in the x direction and 495 in the y direction. And obviously I flipped the y-axis because in QGraphics view, the y points down, but in the polar plot, the y points up. So I need to multiply it by -1 and then offset it by the value. So I hope you understood that. It is basically called an affine transformation, where you move points between two axes and you preserve their relative location. Okay, so moving on, let's go on to the header file. Or actually, let's go on to the project file. So over here, I have to include QSerialPort because I'll be using QSerialPort. I made a separate video on this a while back on how QSerialPort works, and there's also many other videos on it. But just include it here because you need to use it to pass in the serial input and the output to the Arduino board. I have two files, main and dialog.cpp. Dialog contains all my code, main just opens the app. And then I have one image file here, img.qrc, which is this one, and that includes radar.png. So I have a resource file because it is much simpler to specify the relative path of the image instead of specifying the absolute path. And the reason is that I can put this on my GitHub and then anyone can download it and easily locate the file. If it's an absolute path, then obviously you need to do more work. So this keeps things easier. Let me open the dialog header file and see what I have here. So I have included a few more things that we need to use, namely QGUI, math, and timer. Math is for the cos and the sine operations. Timer is optional, you don't need it. I just was experimenting with it. So I can in fact delete this. So moving on, I have slots. So I have one called update the servo, which sends the serial value to the servo. I have the read serial, which will actually read the range from the HC-SR04 sensor. For each button, I have a clicked command which will update the servo angle and then call this method to pass in the value. And then I have one for the slider. If I change the value in the slider, it'll get the value and then update the servo from there. I have a bunch of variables. Now for this one, the main ones are QGraphics scene, which is my scene, my QPix map, which is for the image, the QGraphics item, the rectangle. This will be the point on the radar, which will tell you where the object is located. I have my current angle, which is a float variable, a constant float radius, a constant float angle offset. Now these two will be fixed. This is essentially the radius of the polar plot. The angle offset is that small DT angle which you saw in the diagram. It's a fixed value. I put it as about 0.05 rad, I think. And I have two more variables, the up angle and the bottom angle. So based on the angle offset, you will have two values, upper and lower. My triangle, which is a polygon object, the needle, which will be the needle on the graph. And then obviously I have the ones for the Arduino itself, which is my QSerialPort. I have my vendor ID and product ID. This will be based on whichever you have, but for me it was 9025 and 67. I'm using an Arduino Uno. If you have a Nano, it might be different. And in my other video, I show you how to find it. QString Arduino port name. Bool Arduino is available. And then lastly, I have a few more variables here. Serial data, serial buffer, and then servo setting. And these two are just strings because I save the servo value in the string and then pass it on. So this is pretty much all of my variables and my methods in the dialog header file. Now let's move on to the code. Okay, so for the remainder of the code, when I initialize the dialog class, I need to initialize the value for R and angle offset. Since they are constants, they have to be initialized within the member list, which is done here at the start before you begin the constructor. So I just pass in the values for that. For me, the radius is 445 pixels and the angle offset is 0.05 rad. I load the background image on the screen. So I say scene equals new Q graphic scene this, which is the self, which is the same class. And then I set scene here. Graphics view is this part, the name of my graphics view object. And then I load in the image, which is this one here. I can just copy the path and then paste it there and call the QPixMap to pass it in. And then you add the pixmap on the scene. I then set up a QSerialPort for Arduino, which is this one here. Initially it is false because I need to scan for an Arduino itself. So I do it down here. But before that, I draw my needle so that the needle that moves on the radar itself. So I define two objects, black pen and gray brush. So these are Q graphics view objects which you can use to color a needle. So for me, I have initialized it at 0 degrees. So my upper and lower will be angle offset minus angle offset, right? Because if it's an angle which is 0, it'll be just 0 plus this and 0 minus the angle offset. So that is these two angles here. And then I append it to my triangle. So Q point F, and then again I'm doing the R cos plus 505 and then plus 495. Then here it'll be minus R plus 495 for the Y. So that is simply R cos theta, R sin theta, and then you just do the offsets like this for both the upper and lower angle, so it'll make like a line. And then I add the polygon. So you have to create a polygon which is called triangle. That was Q polygon F. And then you add the polygon and then set the opacity. So I put the opacity because you don't want it to make it completely opaque. It has to be a bit transparent to look more realistic. So I do it here. And then I check which port my Arduino is on. This was taken exactly from the QSerialPort video, and this is quite standard code, so I won't explain it here. You just check if it has a vendor identifier and a product identifier, and then you match it, and then you make it available. And then I set up the port. So all these commands here are standard for QSerialPort. You just set the baud rate, the data bits, parity, stop bits, flow control, and then you just open it and set the port name of it. So I use 9600 for mine, so I just put it there. And then you just connect the slots. For my case, I need to set it to read write because I am reading and writing at the same time. And for me, I have a signal and a slot here. So that's one clarification. If it is not read write, you will have errors. So make sure it is set to that. And then my read serial. Now this will actually read the range from the HC ASR04 sensor. So I just again define a black pen and a gray brush. And here what I'm doing is I'm just getting the serial buffer. So I'm reading the value from the serial and I'm splitting it because I put a comma after each value of the range. And I buffer it because the first value is usually inaccurate, but the ones after are good. So I just pass in the second one here. So this is a string list or an array of strings. I check if it is size of 2, it'll keep going, but if it gets bigger, it'll stop, it'll reset here. And then I pass in the first value of the array, or in fact the second value. I pass in the second value of the array in the range. So the range corresponds to this one here, this label. Since this is a string, buffer split is a string array. That means each element of buffer split is already a string, and then that can be used via set text. You just pass in the string value and then that'll be it. I get my current angle. So the angle is from this one here, the angle setting. I convert that to a float because I need to do calculations with it. I need to do R cos and R sin with that, so I do it here. I get my distance, and then the distance will be the range value from the sensor reading. So buffer split 1 to float. Again, I have to make it to a float because I need to do math with it. So if the distance is less than 100, for me, I said that only show up on the radar if it is less than 100 centimeters for my case here. I get my radius because I need to scale it up, because if you think about it, 100 distance is the edge of the polar plot, so that corresponds to 450 pixels, right? So then each unit of distance corresponds to 4.5 pixels, so I need to multiply to scale it. So that is my radius here, and then I do r cos and r sine of the angle, which I convert to a float, and then I need to transform it again because this x and y is with respect to the top left, but I want it to be respect to the middle of the plot. So then I need to add 505 and then do -1 times y plus 495 again, transform it, and then add a rectangle here. So at that value, xt, yt, 12, 12, I just put a 12 pixels, a small rectangle, and then set the opacity to 0.75. So this part here will actually plot the point on the radar itself. So take a look at this again if you're confused. I'm essentially just getting the location and then putting a point there. That's it. And here, update servo. This will do two things. It'll update the servo label and then also move the needle on the radar, the dial. It'll move it based on what the angle is. So this is how I do it here. I get, so the command is the angle with the user set. So it'll be 45 or from the slider bar. I convert that to radians because I need to do it r cos and r sine. I get the upper and the lower angle, so just add to angle offset and then subtract by angle offset. And then I just edit the points. So triangle 0 was the top point, triangle 2 was the bottom point. If I go up here again, I'll just quickly clarify this. So this part is the middle point. This will always be at the origin. My origin is at 505 and 495, right? Based on the pixels offsets. And the upper and the lower, this will be based on the angle. So now it is 0, but when the angle changes, it should move. So I just change the values over here. Once I am done editing the points of the triangle, except the middle one, since that is at the origin always, I have to use set polygon to update it. So when that's done, I get the command I stored in a temporary variable. Now I divide mine by 1.5 because my servo goes from 0 to 270. So if I specify 180, it'll go to 270, but I don't want that. I want it to actually go to 180. A value of 120 will correspond to 180 on the servo itself. So I have to put a scaling factor of 1.5. If your servo goes from 0 to 180, you don't need to put this. You just have to put 1.00. Okay. But just for me, since my servo goes from 0 to 270, but the command is from 0 to 180, it has to be mapped. I want my command to go from 0 to 120 because in that case, my servo will go from 0 to 180. It's multiplied by 1.5. Okay. And then command new is temper. I just get the command here. I convert it back to a number. And then pass this command new, which is this command divided by 1.5. I pass it to my Arduino here. So Arduino write. This will pass it to the Arduino itself and then update the servo there. So I hope you understood this. It's a bit tricky, but if you break it down line by line, it is quite simple. The main things to consider here is updating the triangle, the needle, and then dividing it by the 1.5 because my servo has a different range. And a few more things like Q degrees to radians. So just go through this line by line and then you should be able to understand it clearly. Update my angle slider and then update servo. I call this function here to update the servo, so it'll call this one and then pass it to the Arduino along with update the needle itself. And then my slider, when I change the value, it'll just update the angle and then call the servo to update it from the angle itself. So this is just like copy and paste it everywhere. Because if I click the button, I also want the slider to move to that angle so I know that I'm there. So I do a set value here. And I can actually show you how this works. So now my Arduino is not plugged in. So I will see errors, but it should see, look, it'll be an error because my Arduino is not yet plugged in, right? So, but I can still demonstrate how this works. So let's see. So for this one, 45, you see how it moved and then updated the slider too. Now I get this error because my Arduino is not inside my computer, so it'll give an error, but just ignore it for now. I'm just showing you that the needle also moved, as you can see. If I move it up, you see how it like moves along and then back. If I go to 90, 135 or 180, it'll move accurately based on my code. So this part, how the needle moves, is done here again. Update servo. So I get the angle and then update my points on my triangle, which is the needle object, and then set polygon, so that'll map it. So my upper is this part, my lower is this part here, and then that's the angle in the middle. So if I say, let's say 75, it'll center at 75 and then it'll draw the upper line here and the lower line there. This is about 0.05 rad, so about 2.5 degrees, quite small but still useful. So yeah, that's my UI working there. And then now we can plug in the Arduino and see how it works. So to run the project, you have to first load the code onto the Arduino itself after plugging in your Arduino to the computer. And then open Qt Creator, load the project file, and then finally run main.cpp. When you do so, you should see that the range immediately appears because the serial is being read each time. And when you move the sensor, if you put something in front of it, your hand or some other obstacle close enough, it should show up on the display itself. It looks pretty cool. Sometimes the servo might spin back to its full range and then come back. If that happens, just wait a few minutes before using a different angle as the input, because sometimes the serial can overflow, and in that case the servo will go to its full range. So just trial and error, just wait a few minutes before changing the angle on the servo, and you should get some good values for the radar display. Try experimenting with different ranges, different angles, see if it behaves as it should. So that is pretty much it for the project. I hope you learned something new in Arduino and using Qt to create an interactive UI. Like this, you can do many projects using serial communication along with a user interface. So with that being said, thank you for watching, and I'll see you in the next video. Take care, have a good day, bye. If you are interested in robotics and motion planning, then be sure to check out my Udemy courses.